Why are neural networks a black box? Imagine trying to follow a recipe that has hundreds of ingredients and steps, but no clear instructions on how each part contributes to the final dish. That's similar to how neural networks work. They are often called black boxes because it's hard to see exactly how they make decisions. When you train a neural network, you give it lots of data, and it adjusts its internal settings, called parameters, to improve its predictions. These parameters are like tiny knobs that change how the network processes information. But once trained, it becomes very difficult to trace how a specific input leads to a particular output. Neural networks are built with many layers of interconnected nodes, or neurons. Each layer transforms the data in complex ways using mathematical operations. These transformations are nonlinear, meaning they don't follow simple rules. This complexity makes it nearly impossible to understand which features or patterns influence the final decision. Unlike simpler models, like linear regression, where you can see how each input affects the output, neural networks hide their reasoning behind layers of calculations. During training, the network adjusts its millions of parameters to reduce errors in its predictions. It learns from large datasets, but it doesn't store explicit rules or explanations. Instead, it develops a kind of internal representation that is not transparent. When the trained network processes new data, it runs it through all these layers, transforming it step by step, but without revealing why it chose a specific answer. This opacity is why neural networks are called black boxes. This lack of clarity can be a problem in real-world applications. For example, in self-driving cars or medical diagnosis, knowing why a decision was made is important for trust and safety. If the system makes a mistake or shows bias, it's hard to understand what went wrong because the internal workings are hidden. That's why researchers are working on explainable AI. They develop tools that help interpret neural networks, like analyzing which parts of the input influence the output most. For example, some methods highlight important features in images or text that led to a decision. These techniques don't open the entire black box but give us clues about how the model is thinking. In the end, neural networks are black boxes because of their layered nonlinear structure and the vast number of parameters that make their decision process complex and opaque. Understanding this helps us better trust and improve these powerful AI systems.